Welcome to qnawire.
The object is rigid and rotates about a fixed axis, and so we can say that the linear velocity would be equaling the angular velocity times r multiplied by sine of theta. And we can then say that the magnitude of the tangential acceleration would be equaling the angular acceleration times r times sine of theta. We know that then the radial acceleration would be given to us by v squared over r sine of theta, and this would be equaling v times v over r sine of theta, which would essentially be equaling v times omega. We know the velocity and the tangential accelerations are parallel to one another, and the angular velocity and angular accelerations are also parallel to one another. So we can then see from the diagram that using the right-hand rule, the direction of the radial acceleration is the direction of omega, the cross product between the angular velocity vector and the linear velocity vector. Also, because the linear velocity vector and the angular velocity vector are perpendicular, we have that the magnitude of the cross product between the angular velocity vector and the linear velocity vector is going to be equal to the magnitude of the angular velocity multiplied by the magnitude of the linear velocity. And so we can then say that the radial acceleration vector is equaling the cross product between the angular velocity vector and the linear velocity vector. This would be proving the relationship for the radial acceleration. We also see that from the right-hand rule, the direction of the tangential acceleration vector is the direction of the cross product between the angular acceleration vector and the radius r vector. The magnitude also, we can say that the magnitude of the cross product between the angular acceleration vector and the distance vector, or r, is going to be equaling alpha r sine of theta. And so we know that from above, rather from this equation, in the previous page rather, this is going to be equaling the magnitude of the tangential acceleration. And so we can then say that the tangential acceleration vector is simply going to be equaling the cross product between the angular acceleration vector and r vector. This would be proving the formula for the tangential acceleration vector. That would be our final answer. That is the end of the solution. Thank you for watching.